3-2, simplifying algebraic expressions, otherwise known as combining like terms. First, here on this board, I would like to introduce you to these four words on the right-hand side: term, coefficient, constant, and variable. These are words that I'm going to use to describe things from now on in mathematics. These are things you're going to need to know the definitions of, but you'll get used to, you'll know them through using them. Terms. We have 4a plus 5a plus 7. This expression has three terms. 4a is a term, 5a is a term, and 7 is a term. 4a, 5a, and 7 are terms. In the expression above, the 24, the c, and the 6 are terms. So terms are the individual pieces in an expression that are separated by addition or subtraction. So we can have 4 times a, that is a term. We can have c all by itself, that is also a term. A coefficient. A coefficient is simply the number that multiplies a variable. A coefficient is simply the number that multiplies a variable. Four and 5 are coefficients because they're the numbers that multiply the variable a. In the expression above, 24 plus c plus 6, is there a coefficient with the c? There is. It's a 1. You'll remember from when we talked about variables the first time, if there's no number next to the variable, there's always a 1 there. So the coefficient there is a 1. So we have terms, we have coefficients. A constant. A constant is simply a number that has no variables associated with it. In this expression, 4a plus 5a plus 7, 7 is a constant. In the above expression, 24 plus c plus 6, both 24 and 6 are constants. And the last word is variable. It's a letter used to substitute for a number that we don't know, an unknown quantity that you are attempting to find. So, 4 words: term, coefficient, constant, and variable. I'm not going to test you on them, not going to quiz you on them. However, as we use them in class and discussions and such, I will use these words to describe things. I'm expecting you to begin to use them as well. So that's the first part. The next thing is combining like terms, what this lesson is really about. We have the expression 7 plus 3x plus 5y plus 4 minus 2y plus 6x. Quite a long problem. We're going to attempt to make it shorter. We can begin with any term, anywhere you like. It's entirely up to you. I prefer to start with the variables in alphabetical order, starting with the lowest one. So we have 3 with an x right here. Are there any other variables with a single x in them? There is down here. So we can actually combine 3x and 6x. We'll get 9x. Moving ahead in variables in alphabetical order, I have a 5y and a negative 2y. What happens when I combine a 5y and a negative 2y? The y stays the same, but the 5 and the 2, 5 minus 2 is 3. So we're left with 3y when we combine all the y terms. Finally, we will look at any other variables. There are none. So we're left with numbers. We have a 7 and a 4. They're both positive, so we're going to add them. 7 and 4 is 11. So 7 plus 3x plus 5y plus 4 minus 2y plus 6x simplifies to 9x plus 3y plus 11. Your work with variables today is simplifying and combining like terms like this. You're not going to be substituting in for the variables today. Today is just sort of keeping track of them and keeping them separated. So we have that. Okay, the order the answer must follow. This is a convention. I happen to like it. It makes the answer look nice. The variables have to be in alphabetical order when you write the problem out. And the constant is always last. You'll notice in this example, we have 10m minus 8n plus 5. The variables are in alphabetical order, and the constant's last. As is here, 9x plus 3y plus 11. Variables in alphabetical order, and the constant is last. Going to attempt a few word problems today. Not too difficult. There's going to be some simplification, some distributive property possibly, so we'll see. As you can see on the left-hand side, the problem reads, you have some cards. Your brother has 15 more than you. What is the total number of cards you both have? A bit of a problem. How many cards do you have? We don't know, so we need to assign that a variable. You have some cards, we'll give you the variable C cards. You have that many cards, C. Your brother has 15 more than you. We really don't know how much that is, but what we can do is express your brother's number of cards in terms of how many you have. If you had 15, your brother has what you have plus 15 more. To find the total number of cards you both have, we have to add what you have to what he has. So that would be C, the first C, and then to that C, your total, we're going to add your brother's. So we have C plus 15. That'll give us the total number of cards. We can simplify this, like we did on the previous board, by combining like terms. We have C's that are there. We have one C in blue and one C in red. When we combine them, we have 1 plus 1. We get 2C plus 15. That's the total number of cards that you and your brother have. In these examples, you're actually not going to find out how many cards there are. It's more an exercise in creating the equation that you would use to find out. Later, you'll be given more information to help find out exactly how many cards each of you has. All right, let's do another one. You've saved some money, and your friend has saved $20 more. What is the total for both of you? This problem is identical to the one we just did. How much money have you saved? M. You saved M dollars. Your friend has saved $20 more. We don't know specifically how much that is, but we can express their total in terms of your total. Your total plus $20. We're really interested in finding out what the total is for both of you. We have to add them together. We take your money, and we're going to add your friends. Now we can simplify by combining like terms. We have a pair of m's that can be combined. So 1m plus 1m gives us 2m and 20. That's how much money you have both saved. Your homework today is in the book, page 106, problems 18 to 54, the evens.